This lesson is about classical or theoretical probability. Let's get started. Lesson 2.1.3 Classical or theoretical probability. By the end of the period with at least 80% mastery, students will be able to identify and explain the three types of probability, solve real-life problems involving classical or theoretical probability. There are three types of probability: classical probability, empirical or relative frequency probability, and the other one is subjective probability. Classical probability or theoretical probability. This uses sample spaces to determine the probability that an event will happen. One does not actually have to perform the experiment to determine the probability. Classical probability assumes that all outcomes in sample space are equally likely to occur. Formula for classical probability. The probability of an event E is equal to the number of outcomes in E divided by the total number of outcomes in the sample space. Or in symbols, P of E equals N of E divided by N of S. Probabilities can be expressed as fractions, decimals, or, where appropriate, percentages. Thus, if one asks, what is the probability of getting ahead when a coin is tossed? Typical responses can be any of the following three. Could be 1/2, 0.5, or 50%. Let's do some examples now. Solve the following problems. Show your work. Number 1. If a family has 3 children, find the probability that all the children are girls. If we recall last time, the elements of the sample space for a family with 3 children are BBB, BBG, BGB, BGG, GBB, GGB, GBG, and GGG. So in this sample space, there are 8 outcomes, and there is only one outcome where all are girls. So the probability that all the children are girls is equal to 1/8. Number 2. A spinner has 4 equal sectors colored yellow, blue, green, and red. After spinning the spinner, what is the probability of landing its color? Since there are only 4 equal sectors, then the probability of getting a blue is the same as the probability of getting a red, is the same as the probability of getting a green, and the same as the probability of getting a yellow, which is 1/4. A glass jar contains 6 red, 5 green, 8 blue, and 3 yellow marbles. If a single marble is chosen at random from the jar, what is the probability of choosing its color? Since there are 6 red, 5 green, 8 blue, and 3 yellow marbles, then the total outcome is 6 plus 5 plus 8 plus 3 equals 22. So, the probability of getting a red is 6/22 or 3/11. Probability of getting a green is 5 over 22. Probability of getting a blue is 8 over 22 or 4 over 11. And the probability of getting a yellow is 3 over 22. Complete the following table for the sample space when you roll 2 dice. Then answer the questions that follow. We already learned the elements of the sample space for rolling 2 dice. And these are the answers here. There are 36 outcomes. So we can now proceed to answer the questions. If 2 dice are rolled one time, list the elements of the events, then find the probability of getting these results. Letter a sum of 5. So sum of 5 could have these combinations: 4, 1, 3, 2, 2, 3, 1, 4. So there are 1, 2, 3, 4 outcomes only. So probability that sum is 5 equals 4 over 36 or 1 over 9. Letter B, a sum greater than 8. A sum greater than 8 are the elements that are included in this group here. We have greater than 8, so it starts with 9 until 12. So there are 10 elements that belong to this category here. So we have 10, and out of the total of 36, you have 5 over 18. Letter C, find the probability of getting doubles. So doubles will only be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So 1, 2, 3, 4, 5, 6. There are 6 of them. Therefore, probability of getting doubles is 6 over 36 or 1, 6. Letter D, a sum less than or equal to 7. So a sum less than or equal to 7 are the elements in this group here. There are 21 of them. So the probability that the sum is less than or equal to 7 is 21 over 36 or 7 over 12. If there are no more questions, then let the students complete the classwork until the end of the period. Have a nice day.